All right, so today I want to introduce to you the topic of evidence-informed practice, at least in the way that we are going to use it in this seminar. So basically, I will try to give some basic informations about the concept, of my understanding of the concept, how we could evaluate or grade or rate different levels of evidence, and why I believe this is so important that we are talking about this in our seminar. Because of publication bias. All right. So first of all, and after writing this, I found out it's also written in the article. So as a preface or disclaimer, this presentation right now on evidence-informed practice is not based on solid evidence. All right. I did not try to look at all the literature. It was like my first introduction of the article on this concept by Wackerhage and Schönfeld. And based on this, I tried to look at some of the references they cited. And so basically, I am today just presenting a narrative. You can be convinced by the narrative. You can be convinced that it's good and that it's maybe useful to work like this in the future. But it's not like that we have good evidence that you should be doing this. All right. It's just like my understanding of how we should be applied sports scientists in the future, and why I think some of the aspects of evidence-informed practice could be useful. So this presentation is not based on evidence, on solid evidence. It basically presents or represents my current and preliminary understanding of the concept. I start thinking about this 1 year ago or 1.5 years ago when the paper was published. From this on, I keep thinking about this, and probably my perspectives will change. Basically, it's, as I said, based on the things that I've learned from reading the article and some other things, and based on my subjective philosophy of science. All right. So everything is visualized or presented by this subjective perspective. And finally, I consider evidence-informed practice a process. So it's nothing that can be there or that it's absent. It's just a process where we should try to understand which aspects of the practices that we do are based on scientific evidence. All right, that's a basic idea. So most importantly, I think it's very useful to be self-reflective of one's own practices. So basically be aware and transparent of which aspects of your practices are evidence-based and which are just intuition, which are just gut feeling. All right, be present about, transparent about your practice, and especially be self-aware. All right, you need to make sure that you know where are you basing your decisions on evidence and where is it just like perception or feeling. Everything's fine, but be aware of where you actually are basing your decisions on evidence. That's the thing that matters from my perspective. The concept, as far as I understood, is found in medicine, so-called evidence-based medicine. And one of the earlier publications on the topic by Sackett and colleagues in 1996, so quite a long time ago, they described evidence-based medicine as a conscientious, explicit, and judicious use of current best evidence in making decisions about care of individual patients. All right. So trying to use evidence and trying to think about the evidence that we have to then care about individuals and patients. So it's basically trying also to integrate individual expertise with available evidence. So it's never just everything should be there in papers, everything should be there in books. It's you should use the information that is there in scientific literature and incorporate this with your experience. That was always the case, at least as they described it quite early on when the concept was established. So basically also good doctors, or for us, good practitioners, good sports scientists, use both individual expertise and the best external evidence, all right? Things that you learned, but also verify with external evidence and experience from others. So in sport and exercise science, in our field, evidence-informed practice, from my understanding, is, or we talk about this, especially in the seminar, about training planning, so the larger structure, but also how can we prescribe exercise and recovery. Again, based on the current scientific evidence and also focus on the current, all right? Things change, literature changes. It's what you have now available or what you could have available. And at the end, if we're thinking about larger systems, larger projects, okay, how do we set up a larger monitoring system? How do we set up working with people, supporting people, training people? It's always about long-term complex plans, all right? And they can never be fully evidence-based. That's the overall idea. It's the same basically with evidence-based medicine or evidence-informed medicine. Of course, there could be some specific decision like taking the drug, yes or no. This could be based on scientific evidence. But if you consider most patients, they have lots of drugs, lots of other interventions. We don't exactly know all the interactions. We don't know what happens at the individual level. Like the complexity can never be fully based on evidence, but some of decisions can be, all right? So basically, it's always about the training plan is more than the things that you can take out of the literature, right? There's always a disbalance between the things that you have to do and the evidence that is available for your specific decisions in your specific contexts. And that's basically the separation or the differentiation between evidence-informed or evidence-based. Evidence-based means a specific decision, I can entirely put this onto evidence. I can directly derive this from evidence. There's a very good controlled trial, for example, a randomized controlled trial, and I exactly want to do the same and 100% do what the study tells me. That would be evidence-based, more or less, not really. But evidence-informed always means, okay, our system, our process, our training process is way more complex, and we try to be aware of at which aspects, at which decisions can we use evidence for some decisions, all right? And be transparent about the level of evidence. If you don't have a clue, but think it's useful, no problem, just be transparent about it, all right? I think you can also be transparent about clients, stakeholders, all right? To say like, this is cutting edge, this is new technology, we have no idea if it's working, based on logic, based on plausibility, it may be useful, and I think it's worthwhile to invest some time in it, and therefore we should try it. So be transparent, even if there's no evidence. It's nothing bad, all right? We are humans, everyone is also basing their decision based on experience, but just be transparent about this. I think this is good practice if we want to be evidence-informed. So basically, the presentation and the things that I have in mind are based on this article, which every one of you hopefully read. And first of all, as this presentation, it's opinion. It was an opinion article. They clarified and they declared this as an opinion article. So again, also their proposal is not based on scientific evidence. It's just a suggested pragmatic strategy of how one could approach training planning if one wants to be evidence-informed. Oh, sorry. So therefore, it's again a subjective proposal from them, and it's not based on direct evidence or research. And basically, they also advocate for athlete, client, or patient-centered approach, right? So they also say, if the client, if the athlete has specific needs or wishes, this is more important than what evidence says. For example, they say, yes, I want to get as big as possible. I want to have lots of hypertrophy. And you have a good idea of how this would be possible. But they say, okay, I can only train for 2 times a week. Then it doesn't matter if the literature says 5 times training is better because the needs of the individual are higher. This is their way of approaching this, all right? So evidence-informed, yes, but especially also individualized and personalized, and the needs and the desires are on the highest level. Again, everything starts with the needs and the wishes from the clients, and this drives all the decisions. So basically, in the beginning, you start to agree on specific goals with your client, with your athlete. Afterwards, you try to write a plan or prescribe training or exercise or recovery maybe, and then discuss if this fits with your client's perception. Again, the needs and the wishes are more important than a potentially more effective intervention. So basically, their 6-step proposal goes as follows. So hopefully you know this. Starting with the overall goal, all right? What do the people we work with want to achieve? Then they suggest that we should break it down into measurable sub-goals, all right? Using the SMART approach to define goals. In the future sessions, we will also talk about if the SMART goals are actually evidence-based and if this is good to set goals like this. But that's their suggestion. Then try to plan testing and monitoring strategies to see if the things you're working with or you're doing with the clients you're working with, if this is effective, all right? See if the responses happen that you expect. Try to choose and pick an intervention to improve the goals, to meet the goals in the future. Base some or plan some key elements. If I want to improve a specific race time over 1 year, what needs to happen in small amounts of times, because this will guide training planning, this will guide the overall structure. And then at the final step, you need to prescribe and plan smaller units, weekly plans, daily sessions, basically. But this is like the process of how one should approach this. And we try to be evidence-based at some of these steps. Right? And the ideal solution would be to be transparent about where can we be evidence-based or not. So basically, if we recommend something to the client, several things that we should consider. First of all, and this is what I would ask you for your projects afterwards. So first of all, for example, make a clear recommendation. What do you think is useful for this setting, for this client? Why do you train? What should happen? Try to then critically describe the evidence base, if there is some, supporting your recommendations. And finally, you should also be able to rate the quality of the evidence that you used for basing your decisions on, and explain and justify this, right? And I like this approach, like basically in your projects, at the end, you will give some kind of recommendations. If you're talking about monitoring tools, if you're talking about recovery interventions, if you're talking about strength training interventions or whatever, training interventions, try to go through these 3 steps, all right? Say what you think is useful, explain what you think the evidence tells you, and then rate the quality and the level of evidence. All right, and explain why you come to this conclusion. So we will see if this is useful, if you tried this out, and these aspects should be in your presentations, no matter how the presentations look like. And one of the aspects of how we can rate the level of evidence is what they suggested. We can use the articles that are presented in the scientific literature. We can look at the studies, and we can put the studies into this evidence pyramid, basically, and see what is the study type of this study that I'm looking at. So for example, if I'm just having some expert opinions that is being presented in articles, this quite often you see editorials, where the editorial staff, the researchers that are running the articles or running the journals, sorry, the researchers that are running the journals, they also write editorials of what they think how research and practice should look like. All right. Many articles that are quite clear in their recommendations are editorial articles. And this is also expert opinion, right? And this is based on this understanding, the lowest level of evidence, because it's just your opinion, basically. Opinions can vary between subjects. And of course, if we have systematic reports of things that worked out, for example, how do the best athletes in a specific area train, this is maybe a little bit better evidence than just someone's opinion. Then we go to observational studies, where we do this in a larger group. We look at a larger training group. We look at the best athletes in an entire field, for example. Or we're just running some observational studies with vaccines, which is also very important, all right? Looking how it happens, what happens if we roll out the vaccines in public. This needs to be also done in observational style. We cannot always use randomized controlled trials. We can use controlled trials without randomization. So just having 2 training groups, for example, one group does one thing, the other group does the other thing. Still, groups can vary. So therefore, it's useful to have randomization as a better strategy of reducing publication bias. So basically, the publication type or the study type hopefully is a little bit better. And at the end, what they suggest is, okay, the best evidence is potentially from meta-analysis or systematic reviews, which basically screen all the different aspects. This pyramid of evidence is, however, only focusing on one aspect of evidence, all right? It's just focusing on the study type or the publication type. And if we look at this, it comes again from evidence-based medicine. Yes, there is some basic hierarchy of which of the publication types reduce bias, but with reducing bias, we also often we are reducing external validity. So for example, a randomized control in a specific group, we are very strict about what we do, but a randomized control trial never reflects actual practice, because actual practice is not randomized. People behave differently, people use different interventions at the same time, and therefore reality always is different than a randomized control trial. So we need to be clear about, are we reflecting reality? And reality is basically good being observed with observational studies compared to randomized trials. Randomized trial, they try to reduce bias. They try to be very clear about answering a question. They are not good in reflecting reality. Reality is way more complex, way less controlled, right? Nevertheless, they suggest there's way more fluctuation between study types because every study type can be good or poor quality. So it's not like very clear cut that always, for example, a case control study is of poorer quality than a cohort study, than a randomized trial. There is some substantial overlap. And what I think is very, very important, systematic reviews or meta-analysis are just a way of evaluating the evidence, all right? So a systematic review or meta-analysis is not necessarily better than an individual study, because if I'm reviewing poor quality study, then the review comes to poor quality evidence, all right? It's a systematic way of evaluating the evidence, but it doesn't tell me that the quality of the evidence is better, right? That's the standard or traditional principle of garbage in, garbage out, all right? If it's just garbage studies, the evidence will not be better. It's just like, okay, I know how garbage the studies are. That's basically it. So a systematic review or the things that you read in meta-analysis is not necessarily good evidence. It's just a systematic approach of evaluating this and trying to interpret this, what happens or what's standing in the original literature. How can we go about this? This is also mentioned in the article, and we will quickly look at this. So for example, the Oxford Center of Evidence-Based Medicine, they have a specific way of evaluating levels of evidence where there are different study types, as you can see. So basically the best study type for therapy or prevention, for example, would be level A1, which is a systematic review of studies, which all are quite homogeneous in their results, all right? Many, many high quality studies of randomized controlled trials, so potentially the best study type for intervention studies. So looking at various randomized controlled trials, and the randomized controlled trials all are quite homogeneous in their evaluation and their results, all right? It's not like one randomized trial says, oh, it doesn't work at all, it's huge problem if we do this, and the other trial says, yes, it's the best we can do. No, the results should be quite homogeneous, and there are ways of how you can evaluate this, and there are ways of how you can statistically test, for example, if the results are homogeneous or heterogeneous. So basically level A1 evidence would be a systematic review for interventions looking at various randomized controlled trials which find quite homogeneous results, right? And then you can go down. So basically there are different ways of how you can evaluate and grade different studies. And at the end, based on the things you're looking at, you come to an overall evaluation, a grade of recommendation. So basically you say, for example, level A recommendation would be the entire evidence is based on level 1 studies, right? If I have poor level 1 studies, for example, it would only be that I get a level B recommendation. Or for example, level B recommendation would be that all the studies that I'm looking at are only of level 2s or 3s, right? So a very specific way of how you can look at the literature, place them to different categories, and at the end say, okay, currently my recommendation of how you should proceed is based on level A, B, C, and the individual studies are also evaluated from levels 1 to 5 with subcategories, right? Very specific and clear way of approaching this. a little bit easier way of how to do this is the so-called grade system, where the quality of evidence basically has 4 categories, from very low, low, moderate to high. And basically on the left-hand side, you can see the more up-to-date definitions. Low quality evidence means that we have we have very little confidence that in the effect estimate. All right, so we have, for example, meta-analysis, which says there is a moderate effect size. If we look at all the studies, there's a moderate effect of this intervention that it works, and it works at a moderate level. So for example, strength will increase only at a moderate level if we are doing a specific type of resistance training. But we have little confidence that it's actually moderate. It could also be small, it could be trivial, it could be large, right? So we have less or little evidence that this result that we have in the literature is actually true in the future, right? So basically we need additional studies, and our summary can vary quite a lot, right? Yes, we have some studies, we have 3 to 5 studies, for example, and there is an effect we can suck out of the studies, but at the end, we are not really sure if it really holds, right? If we have hundreds of studies, which are, and they show a very robust evidence level, and we think 2 studies more, they don't make a difference, the effect that we are looking at is quite robust, and future evidence will not change our conclusions, then we would say we have high levels of evidence, right? So basically, you look at the literature and you make an evaluation. Do you think in the future, if new studies, new evidence comes in, that your conclusion will change, will be able to change? All right. So quite simple way of evaluating the studies, or evaluating the quality of the studies or the quality of the evidence. However, you can also make quite strong recommendations based on poor evidence, all right, based on your experience. That's possible, but you don't know if this holds up if lots of research comes in the future. However, we have to be aware that the quality of evidence is not the same as basically the strength of the recommendation, right? I can say, no, you definitely have to eat only half of your meal size to reduce weight, even if there's no evidence supporting my claim, all right? I can be very clear, very strong about my recommendation that I'm giving you, because I think this is the way to go, although there's no evidence, all right? So the level of quality of the literature has nothing to do about the strength of our recommendations. For example, we can also have very good evidence for an intervention of aspirin, for the drug aspirin in a certain context. We want to use this drug in another context. We are not so sure about this context. We still can make a very clear and strong recommendation, although for this situation, the evidence is not good. That's possible. At the same time, we can have very high quality evidence, but we're not so sure about what to do right now because the situation is entirely different. So the things that also influence the recommendations are, of course, on the one hand, quality of evidence, but also the uncertainty about the balance between desired and undesired effects. So yes, we know it works. Maybe we have good evidence that we know it works, but we don't have an idea about undesired effects. Side effects, what happens if I do a specific interventions with the entire social construct of the persons? Will this break down? Will they reduce their academic performance because it's just too demanding, the specific way of training, for example? So there are other things that you should consider when making a recommendation. It's not just about the evidence and the quality of the evidence. And also what they do, for example, we have, based on this evidence pyramid, some studies in general, they are considered to have a little bit higher starting quality, but nevertheless, the quality of the evidence can be higher or lower if certain aspects appear, all right? If the study has high risk of bias from an initial randomized control trial, which we say is usually high evidence, it would be downgraded because there's still some risk of bias in this publication, all right? So several study types, they start with something like an initial level of evidence because of the way the studies are conducted or what the studies can provide. But nevertheless, there's also good possibilities that you can up or downgrade the quality of evidence. So I'm looking into many tired faces and many questions I see on your foreheads. Basically, it's just about, I want to show you what goes into the process of rating the quality of evidence, and also that quality of evidence is not the same as making a recommendation, and show you some things where you can look up if you need to do this for your stuff. All right. Examples. What's the evidence? So if we look at the WHO guidelines for physical activity and sedentary behavior, so the World Health Organization, all right, the quite well-known recommendations of how much physical activity should there be in your lives, all right, for health reasons. The classical recommendation is at least 150 to 300 minutes of moderate intensity aerobic physical activity. If you're exercising a little bit more intense, the training duration per week can be lower. All right, this are the common recommendations from the World Health Organization on physical activity. And what they do, if you look at their literature, and I wasn't aware about this, is they say for these statements we have moderate certainty evidence. All right, they use the grade system and they rate the level of evidence for their statements. And they also say our recommendations are quite strong. All right. So they use exactly the concepts that I talked about. They use the grade system and they separate between recommendations and the quality of evidence. So for each statement within the World Health Organization guidelines, you are able to find the level of evidence and the recommendations, and they are transparent about this. Right? And that's a good thing. In their documents, you can also find out, they write how they evaluated the evidence. They assessed the evidence. So for example, if we look at the working group who come up with their recommendations, if we look a little bit more into details, we find that there's a high certainty of evidence, for example, that physical activity is associated with lower risk of all-cause mortality and cardiovascular disease. So the evidence for physical activity lowers your all-cause mortality, and that physical activity lowers your cardiovascular diseases. They consider this to be high-quality evidence. All right. However, if we look, for example, that physical activity also improves mental health, cognitive health, or sleep outcomes, there we only have moderate certainty, moderate evidence. All right. And for example, they only have low evidence that the benefits actually outweigh the harms. That's good to know, all right? So yes, we're quite clear that we can affect some relevant health aspects, but there's not good evidence right now that the benefits actually outweigh the harms. It's still plausible at the moment, but we don't have good evidence for this statement, all right? We don't know if the side effects of exercise are so small that the benefits actually outweigh. We need to find out, and they are quite transparent about this. And there's actually, to show you how evidence evaluation could look like, and to be honest, I have no idea if their evaluation of evidence is good. In the article, you also read that the ACSM has some strength recommendations of how you should strength train, and they make clear recommendations. They also evaluate their evidence, and other authors said their evaluation is poor. So I have no idea how good this is. At least they are transparent about it. So let's take a look how these documents look like. Wait a second, I need to find this document again. Yes. So basically there is I can't read this, more than 500 pages of evidence evaluation, which is basically an appendix to their recommendations. And if we look to this document, for example, they also say, yes, they're using the grade system, how they're also using the PICO system, which you will hear in other classes. And if we scroll down, all right, these are, for example, the reviews that they consider. So they are doing umbrella reviews. They are doing reviews of reviews for their recommendations. And for example, the first review they considered is this guy or girl, I'm not exactly sure, from 2017. And they say, based on the rating of on the ratings of the grade system, or using the grade system for evaluating this review. And this review has moderate evidence, right? There are other reviews that have low evidence, critically low evidence, and so on and so forth. And if we go further down, they also, based on the evaluation, say at which aspects do we have good or poor evidence. So for example, is there evidence for publication bias? Was there a risk of bias assessment? Did they consider the funding sources? And this is quite common in medicine, at least it's a big problem, that there's no information about the funding sources. So we have potential conflicts of interests, which also can undermine level of evidence. And basically, you can see how they rated each individual study, how they came to an overall conclusion, and what is basically the basis for their recommendation of moderate, high, strong evidence for their recommendations. So I think this is quite good practice to be transparent about the way of how you approach rating evidence and making recommendations. So this is how the WHO does it. If we look at individual studies, and this is a paper that I know quite well, and that's in my topic area. So for example, what is a good way of reporting in a meta-analysis, all right? A meta-analysis is just something written down of how people looked at the literature and evaluated the literature. And then in the article that we read, they basically report what they did. And this is an example of how good reporting looks like from, for example. So they looked at validity, reliability of submaximal tests to monitor aerobic fitness. And for example, based on the studies they looked at, they also did a risk of bias assessment. So all of these studies, how many of these studies were clear about, for example, selection of the participants, some confounding variables, blinding, outcome reporting, or selective reporting, basically. And you see an evaluation of the studies that they included, right? They do a risk of bias assessment of the studies they included, and they are transparent about this. They display the results of their evaluation, the same thing that we saw at the WHO. And for example, they also did a meta-analysis, a quantitative summary of the validity and the reliability. And you see the individual effect sizes, and effect sizes should look like this. All right, we have a funnel plot here, and basically what you need to look at, that most of the effect sizes are within the triangles, basically, and that they are systematic and symmetric. All right. In many cases, you see that the effect sizes are shifted to one part of the curve, and they are all shifted to being significant. All right. So only significant results are reported, non-significant results are not reported. Here we can see that we have a quite good literature reporting because we see everything. All right, we see good and we see positive and negative values, and so this basically a good indication that we probably can trust this meta-analysis quite well because they are at least transparent. We can argue if, okay, there are lots of yellows, so where people just didn't mention if the information is there or not. So we can argue about the risk of bias, but at least we don't see a clear publication bias when we look at the effect sizes. And for example, I also want to show you this example of how it could look like. So what they also did is, for example, they reported everything, how they proceeded the meta-analysis, and published all of these proceedings, including data and code, for example. And it looks like this. And so they published everything at the Open Science Framework. So all of the supplementary material are also available here. So for example, every calculation they did, every data point, you can also find in their data files. They analyzed they run the meta-analysis with R, like they created some code to run the meta-analysis in R. There you can find the entire code. Did they make some errors in their code, for example? And what is also quite nice, in the supplementary files, they also used reporting guidelines. So for example, if you're writing down a meta-analysis, there are things that should be in the meta-analysis, all right? And we have guidelines for this. A good meta-analysis should be conducted in accordance to the PRISMA guidelines, which stands for Preferred Reporting Items for Systematic Reviews and Meta-Analysis. PRISMA checklists, all right? So there are lots of things that you should report in your article on a meta-analysis that people understand and have all the information to evaluate. And they did all this. So they, for all the things that they should report, they specifically mentioned where they reported. They also explained how they reported it. So basically, they're extremely transparent about everything they did and where you can find this information in the article. All right. So it's very good and easy for you to check if they did a good job. And that's, from my understanding, a good example of how good meta-analysis could look like, that we are able to evaluate the evidence. All right. And at the end, that we are able to trust what the authors did, because at least they were very transparent about this. And if they did big errors, everyone can see this forever, because this is in the scientific literature, it will not be deleted. And that's at least a good thing. Why is this needed? Because we also have lots of errors in meta-analysis. So this researcher group looked at the 20 most highly cited meta-analysis in strength and conditioning research. And they found from these 20 highly cited meta-analysis that 17 of these 20s had at least one statistical error. All right. Meta-analysis, they make a statistical and quantitative summary of the evidence. So for example, we have lots of interventions. They say the intervention works from low to large effects. Meta-analysis puts all the effect sizes into one bin and makes an average effect of everything. And is this calculation, because at the end it's a type of calculation, is this good or not? Because it's statistics. And they found there are statistical errors. For example, if you look at the meta-regression of what the effect sizes for sprint interventions are compared to squat performance. So does one maximum strength correlate with sprint performance? Right. This is the summary of the studies they looked at. And in red, you find basically studies that are poorly reported. And especially what you find is that this one study is an extreme outlier, right? So if we look what this study tells us, this study tells us that we have an effect size for the squat training of 15 standard deviations. So the intervention group was 15 times better, 15 times the standard deviation better than the intervention group, than the control group. And sprint performance was improved by 6 times the standard deviation. These effect sizes are completely implausible. There's no intervention in the world which could lead to these large effect sizes. All right. So we have variability between people. Some people respond better than the others. We have a standard deviation. And this study says the intervention is 16 times better than the standard deviation. This is just physiological, completely implausible. Usually in medicine and psychology, we have very oftentimes effect sizes that are smaller than 1, quite often quite close to 0, right? Between 0 and 1, this is the typical range of effect sizes. In sport and exercise science, we typically have larger effects if we're looking at untrained people, and this is implausibly large. So a huge error just because they took the wrong numbers out of the papers of the original articles. And for example, this is how, if we reanalyze the effects from the original studies in a proper way, if a statistician does it, if there's a proper weighting, for example, from a correlation of 0.77, we only have a correlation of 0.5. So the actual effect size is way smaller if we properly evaluate the effect sizes. And this is the one of the most impactful meta-analysis in our field. At least extremely many people cite this meta-analysis, and it's flawed. Same thing, another meta-analysis, they give some examples of meta-analysis. Here are some that also say we find effect sizes of 8 and 6 compared to the other studies, which always show way, way, way smaller effect size, all right? Usually in sport and exercise science, everything to 1 or 2, maybe it's realistic depending on the intervention, but above 2, it's very, very uncommon, all right? And effect sizes like 6 or 8 are completely implausible. And you wonder, why did the authors did not spot this error? Why did the reviewers did not spot this error before it got into the literature? All right, this is for everyone who's understanding statistics, it's quite clear that this cannot be true. It's completely implausible. And at the end, it was just because they exchanged the standard deviation by the standard error. All right, so they looked at the original papers. They took out the values to calculate the effect sizes. And instead of using the standard deviation, they used the standard error. The standard error is always way smaller than the standard deviation. Then they created the standardized effects, and this is why the effects are way too large, just because people are looking at the wrong values. All right. So we have some problems. Even if we look at the most highly cited meta-analysis, and if we look at the highest level of the evidence pyramid at meta-analysis, all right? And so this is just one example of how meta-analysis could be wrong, and you need to be critical about what they actually did if the values are plausible. You find the article here, everything's hyperlinked, and there's also a talk from the statistician who was on the team at YouTube. I also linked you this talk there, which explains different concepts in more detail and how we could go about this. All right. It's already a very long input from my side. I want to take a short break and ask you if you are willing and interested enough to also see on a larger perspective what is wrong with science and in our field. Right now, there were just some examples. We saw examples of how good reporting and quality evidence rating of the level of quality for the WHO, for example, or for a meta-analysis that I found good, how this could look like. I showed you one example how meta-analysis can go wrong and that they also can contain errors. And now in the next part, I would give you some examples of how these things look like on a scientific, on a field perspective, if you're still interested enough. Nevertheless, I would make a short break to ask you if there are questions so far. Do you have any questions? And do you understand why we talked about this? Okay, so I don't think it's necessarily a problem for training, but I believe that we should try and we should strive to do better, way better, all right? Because, I don't know, that's my perception. I'm not able to do it right now, and this is what I'm telling you right now. You know, this is why also the course structure was restructured. This is why this is the first time in there. I'm still thinking about this. Maybe this presentation looks differently next week, next year, and so I still have no idea how to do it. But I think as a field, we should try to go in this direction, right? It's not just, yes, I found one study. I mean, we are doing research and we're having this field. There's money going into this field for good reasons, all right? And so if possible, I think it's useful and beneficial for our clients to know about this evidence, to better be able to evaluate the different choices that we have. All right. For example, it would be good that I know how heavy should strength training be to introduce hypertrophy. That's something useful if I want to introduce hypertrophy. I also can just try out. All right. It worked in the past and it will work for the future. But I think the common idea of why research is useful, of why hopefully sports science education can be useful, is that we can learn from this and that it's useful for practice. And therefore, it would be useful if you find some ways of how this could look like, right? Hopefully, the WHO does a good job. Hopefully, we can trust the WHO. Hopefully, there are some people who are evaluating this and who are putting their criticisms into the scientific literature that we know, okay, we can trust this. That would be good. In many cases, I think we don't even try to go in this direction, right? When I write a training plan, I'm not doing this right now. And I think that's a problem because I could do better. I cannot do this for every part of my decision, but I think we could do better. And as a field, we could move forward, all right? If every one of us would do that in the future, we could say, okay, this is my idea of how training looks like in this and that situation. I know because I went to conferences, I looked at different research articles, I looked at different YouTube talks about some research articles, for example. And based on this, I think the evidence for this claim is level A, B, C, whatever. All right, there's good evidence, for example. And that's the reason why I'm working the way I'm working. I think that would be useful. And in the end, it should help to better decisions. Right. So I think it would be good if our entire field goes like this, if the entire education is in this direction, that everyone's transparent about at which point of the evidence level are we currently at, what are we teaching you. Why I tell you in the beginning of the seminar is I will not give you solutions is because the things I'm teaching you have low evidence, because I don't know the entire area of the field. I present you a way of working, which I think is useful, all right? And I present you how you are able to evaluate the quality of monitoring tools. For example, I want you to be able to evaluate this for yourself in your situation. But I'm not able to tell you right now, this tool has good evidence, this tool has poor evidence for this and this level. But we should go in this direction, right? So I think we should be able to be transparent about this, and especially we should be aware about this. I know in many situations that I have no clue about the evidence, and I think this is good because now I know where to look at. Now I can rate. Is it more important to spend my time looking at monitoring? Is it more important to spend my time for interventions? Is it more important to spend my time at goal setting? I can make an informed decision, an informed judgment about where I should spend my time on to hopefully work better with the client. All right. Or if things not working, then I know I need to look at the literature to hopefully find some good solutions. So I don't think it's a problem in general, but I think we should, there are some good reasons that we should move in this direction. So brief recap, summary, and then maybe we move on, all right? I would prefer to move on a slight bit because based on the eye movement, I think some people are still a little bit active enough to listen to stuff. So we talked about so far, what could we understand with the term evidence-informed practice? We all agreed that we're already moving in this direction compared to 10 years ago, for example. All right, now we have a term, how we could call this, that's good. We introduced a bit what the authors, Wackerhage and Schönfeld, think about the term evidence-informed practice. I also showed you my narrative of what I consider this concept currently. I showed you some examples of how evidence could be rated, the level of evidence can be rated, and also that level of evidence has to be similar to the recommendations, all right, the strength of the recommendations. And I showed you how rating of evidence could look like, how the WHO does it, how a good meta-analysis, what Christoph, trust me, what Christoph thinks is a good meta-analysis, because I spent lots of time at this paper looking, oh, they reported the things, I checked, did they report everything well, because it's a topic of my interest. I checked some of the results, and I'm personally quite confident in their findings, right? This is how one could approach. I showed you also afterwards why this is important that we have this type of transparency, because meta-analysis also contain errors. Meta-analysis is a statistical tool to quantitatively summarize evidence, all right? A systematic review just systematically goes about the literature and writes a narrative which people can follow. A meta-analysis also makes a statistical analysis of the average effects, among others, right? And there are statistical errors in this statistical calculations. So I would now like to also show you some things about field-wide publication bias, why I think rating the evidence is important for science and therefore also for practice, all right? I think it's useful that you know that research right now is not perfect. This is why this education is so incredibly important, that you are able to evaluate the research that you're reading yourself, that you are able to make a judgment for yourself. Is this good quality or not? Then you can decide for which situations you are looking at evidence or not, right? Will you agree to still look at this for a short amount of time? all right? So basically, again, my narrative is, I believe, or my understanding of science, of research is everything that uses systematic activities to expand knowledge, all right? We try to be smarter afterwards, after we did some research, some researching. It also incorporates rigorous methodology, and this is needed to derive robust results, all right? That a study and a meta-analysis yields robust results, that we can trust these results. Therefore, we need rigorous methodology. The thing is, scientific evidence or research is more or less comparable to the scientific literature. There are more studies out there that are not published. We can't know about them, all right? We don't know if there was ever a study that tells us something else if it's not published. So therefore, the scientific record, the science, the research is basically, from my understanding, equivalent to literature. This is the only thing we have, right? We don't know if there are other studies being conducted. If they come to other conclusions, we only can look at the literature. So therefore, if we want to evaluate the quality of research, we only can look at the literature. This is why the literature is so important. And to be able to do quality control, we need to have all the information available, all right? So open science basically means to be transparent and open about the things that you did in research, and also write about everything you did. And the question is basically, is open science good science? No, I don't think so, because you can be very transparent and open, but still make mistakes. So therefore, the quality doesn't have to be good. But I believe good science needs to be open, because otherwise no one can evaluate it, all right? Just writing something, hey, I did a study and I found this effect. I don't even show you the statistical results. It will not be useful because no one can evaluate if the study was good or not. And if we're thinking about science, scientific process, basically we come up with a problem, or we have a problem. Sometimes we specify hypotheses, then we do a study plan. We afterwards collect some data, we analyze the data, we draw some conclusions, then we can debate and potentially publish our findings, and therefore we move on, all right? Work on another problem, work on a problem in a different way. And basically open science tries to be open about all these different aspects in research. And the question is, why do we need it? Because currently, I think the openness in science is quite small. We need to actually look for this quite hard to find informations to be able to evaluate the quality, and this is not good. This is what all the risk of bias assessments show, that in many cases, we don't know if there is some evidence. We don't know if the people did some randomization, if the people did some blinding, because they don't report it. So we don't know if the study was blinded or not. They are not saying if the study was blinded or not. And that's a problem. We cannot evaluate the quality. Maybe it's good, maybe it's not. So therefore, there's lots of trust. But the problem is, we know there are good reasons that the published literature is not comparable to the science that happens, because in many instances, non-significant results will not be published. Only the significant results will be published. Sometimes people look at the results and say, oh yeah, I had this hypothesis all the time. So of course, that's the case. So I write this into my introduction. That's my hypothesis. And look, my pretty study found exactly support for this hypothesis. This is what's called hacking. And some people just think, the study was boring after all. I'm not publishing it at all. All right. So we have additional publication bias. And we also can see that we have publication bias, because if we look at very high quality evidence, if we look at the Cochrane database, which looks at randomized controlled trials, and this is a review of randomized controlled trials of the statistical effects that are reported in the literature. What do these studies find, which we consider have high quality? We do observe that the effect sizes in the literature look more or less bell-shaped, look normally distributed, okay? This is a good evidence base. This is a good scientific literature, because we have full reporting. We do see some positive studies. We do see some negative studies. We see some studies which don't find anything at all. This is what we expect in the way we perform research. if we look at research more broadly, if we look at more than 1 million statistical values in PubMed, we find a distribution like this. So not everything is reported. The things that are in the middle, which should be there if we have a good literature, are not there. And by coincidence, maybe not, these are effects that would be non-significant, all right? So if we look at the statistical effects that are reported in the literature, we find that there is an implausible distribution of effect sizes of statistics that are reported. Non-significant effects are not reported. They should be here. If we have high quality, it looks like this. If we have normal quality, this comes out, all right? And if we look at sport and exercise science or sport and exercise medicine, we also see the same in our field, all right? So for some reason, people don't report non-significant effects. So if we do a meta-analysis for some topic on this, we have a problem because we take an average effect of something like this, we have a problem, right? Literature isn't complete.